Mm. Hi friends, today we'll be dealing with the simplex method of solving a linear programming problem. So basically there are two methods of solving a linear programming problem. One is the graphical method and other is the simplex method. Today we'll be dealing with this simplex method. So it's actually a lot of calculation which comes in the construction of the simplex table. So I'll just give you an introduction to a simple and easiest way of solving the linear programming problem. So basically what we should be doing here, just look at this problem here. It's a linear programming problem and we have to maximize C equal to 3000 x1 plus 2000 x2 subject to the condition 5x1 plus 2x2 is less than equal to 180, and second condition is 3x1 plus 2x2 is less than equal to 135, and x1 is and x2 is greater than equal to 0. So in simplex method, what we are doing is we actually introduce slack variables to make this inequality equation to a equality equation. So this equation, the first equation, can be rewritten as 5x1 plus 2x2 plus s1, and notice the equality sign here, 180 equal to 180. Similarly, the second equation can be written as 3x1 plus 3x2 is actually 3 here. Sorry with the problem, it's actually 3 plus s2 equal to 135. And we rewrite the objective equation. This is the objective equation as C equal to 3000 x1 plus 2000 x2, and we attach the slack variable which we have added here to the objective equation, plus 0 s1 plus 0 s2. So this is the transformed equation. This three inequalities has been transformed to this form over here. Now what we can do is we can just ignore this 3. We will be dealing with this again. You can completely ignore these 3 equations. So the basic idea what simplex method uses is we have to construct the simplex table. So for constructing the simplex table, just note down this abbreviations here: PPU. I'll just explain what this but just note down this: PPU, BV, CJ, SV and R. So this is the first simplex table we are creating. It's something like this is the simplex table. So PPU stands for parts per unit, BV stands for basic variable, CJ is just a parameter, SV is solution variable, and R is the ratio. So we have to transform this three equations into the table. So for doing that, first what we should be doing is we have to note down this variables x1, x2, s1 and s2 into the table. It comes as x1, x2, s1 and s2, and the coefficient of the variable should be written on top. It comes as 3000, 2000 and 0 and 0. Next thing is the solution variable which we are writing here. So for that you transform this first equation. So what is the coefficient of x1 here? x1 corresponds to 5 here, x2 is 2, s1 is 1 and s2 is 0, and the solution variable, this 180, should be transformed here. And what is the basic variable which we have introduced here is s1. So the first equation is transformed, so we can forget this equation. Now take the second equation, that's 3x1 plus 3x2 plus s2 equal to 135. So for that, coefficient corresponding to x1 is 3, x2 is also 3, s1 is 0 and s2 is 1, equal to 135 here, and we have introduced the slack variable s2 here. And in this parts per PPU, parts per unit, what we should be doing is we just write the value corresponding to this s1. What is on top of that? It's 0. So just transfer the same thing here, 0, and also corresponding to s2 is 0. The first is 0. So this is the transformed equations. So we can forget these three equations here. Now the next step, what we should be doing is we should calculate Zj. So for calculating Zj, it's actually x1 corresponding to this x1, it's 5 into 0. I'll just write down here 5 into 0 plus 3 into the 0 into 0. So that's 0 plus 0, so that's 0. Similarly here it's 2 into 0 plus 3 into 0. Here also it's 0. 1 into 0 plus 0 into 0. This is 0 and this is also 0. Next thing we should be doing is Zj minus, I'm sorry, it's Cj minus Zj. Cj minus Cj is this 3000 minus Zj. 3000 minus 0. Here it's 3000. 2000 minus 0, it's 2000. 0 minus 0, 0, and 0 minus 0. This is 0. So this is the first simplex table which we have created. So we should be doing we should be constructing the table in such a way that the Cj minus Zj is either 0 or is negative. So here it's positive, so we should be constructing the next table. Simplex table 2. So for constructing the simplex table 2, I'll just give a introduction to few steps, which just pause the video and follow the steps. It actually looks complicated, but it's pretty easy if we just follow the rules. So the steps are, just pause the video and write down the steps. It's easy actually. Step 1, key column equal to highest positive value of Cj minus Zj. I'm sorry with this, it's Cj minus Zj. In the second step, ratio equal to solution value divided by element of key column. Third is key row is equal to lowest positive value of ratio. Fourth is the outgoing variable, that's equal to the variable corresponding to the key row. Incoming variable is the variable of the key column. In the sixth step, the key element is the intersection point of the key row and the key column. So we'll follow these steps in our problem to construct the second simplex table. So for constructing the simplex table, second simplex table, we write the same stub here, same thing here, PPU, basic variable, Cj, solution variable, and the ratio. In the second table, in fact in all the simplex table which we construct, this step, these values will be same, so you can just copy them once more. It's x1, x2, s1 and s2, the same coefficients here, 3000, 2000, 0 and 0. Now we'll just follow the steps which we have just discussed here. Key column. Key column is the highest positive value of Cj minus Zj, which is Cj minus Zj. This is Cj minus Zj, and the highest positive value is 3000 here. So corresponding to 3000, this column can be called the key column. You just write key column here. Now the second step, a ratio. This ratio is the solution variable by element of the key column, which is a solution variable. This is 180 divided by element of key column, so 180 divided by 5. Solution value divided by the element of key column, 180 divided by 5, so it comes as 36 here, and similarly 135 divided by 3, it comes as 45. So this is the value of the ratio. So we have completed the second step. Now the third step, the key row. The key row is the lowest positive value of ratio, which is the lowest positive value here. of ratio, it's 36 and 45, so the lowest positive value is 36. So corresponding to that, this is the key row. Now the next step is the outgoing variable. Outgoing variable is the variable of the key row. So this is the key row, and this variable is the outgoing variable. Similarly, the incoming variable is the variable of the key column, which is the key column. This is the key column, and this is incoming variable. And key element is the intersection point of key row and key column. This is the intersection point, key row and key column, the intersection point. This is the key element. So we completed the 6 steps which we have discussed, and we'll construct the second simplex table. So for constructing that, first thing we should be doing is we just check what is the outgoing variable. This S1 is the outgoing variable which we have found out here. So we can delete this S1 and bring in the incoming variable, that's X1 here. And corresponding to X1, it's 3000. Just on top of that, it's 3000. And similarly, no change in the second variable, it's S2, and corresponding to S2, it's 0 here. Now for construction of the key row in the new table, just follow this one. We can write as step 7. It's new entry in key row equal to key row element in old table divided by the key element. So here it's in the old table, the key row is 185, 2, 1 and 0. So for in the new table, it will be 180 divided by the key element, that's 5. So it comes as 36. Here it's 5 divided by 5, so it's 1. 2 divided by 5, it's 2 by 5. Here it's 1 by 5 and 0. And the second row, for obtaining the second row elements, what we should be doing is just write the old values in the old table. 135, this thing 135, 3, 3, 0 and 1. 135, 3, 3, 0 and 1. Just do this following operations. 135, just put minus, 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 bracket, 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 and just copy these elements of the new values in the key row. That's 36, 1, 2 by 5, 1 by 5, 0, into into what should we look for getting this value. What we should be looking is we should look the key column and the value which corresponds to the second row here. That's 3. This 3 into 3 into 3. Here also 3 3. Just close the bracket. Equal to equal to equal to equal to equal to. So this value comes as 135 minus 36 into 3. It comes as 27. This comes as 3 minus 3, that's 0. This is 3 minus 6 by 5. That comes as 9 by 5. Here it's 0 minus 3 by 5 and 1. So these are the new values in the second row. So it is 27, 0, 9 by 5, minus 3 by 5 and 1. Now similar to the first simplex table, we calculate the Zj value. Zj is actually 1 into 3000 minus 0 into 0. So this is 3000 here. 2 by 5 into 3000 minus 9 by 5 into 0. So it's 6000 divided by 5. It's 1200. Similarly, 1 by 5 into 3000 minus 3 by 5 into 0. Here it comes as 600, and this is 0 into 3000 minus 1 into 0. Here 0. Next step is Cj minus Zj. Cj is this 3000 minus 3000 is 0. 2000 minus 1200 is 800. 0 minus 600 is minus 600, and here it's 0 minus 0, that's equal to 0. So we have constructed the second simplex table here. Now what we should be doing is we follow the same, since there is a positive value here in Cj minus Zj, we should be constructing the next simplex table. So for construction of the next simplex table, we follow the same steps which we have discussed, same 6-7 steps. So we construct the third simplex table. So the parameters are same: PPU, basic variable, Cj, solution variable, and the ratio. So what is the first step? It's a key column. Key column is the highest positive value of Cj minus Zj, which is the highest positive value here. It's 800. So this is the key column here. And next is finding the ratio. So for finding the ratio, it's ratio is solution value by element of the key column. So solution value, that's 36, divided by element of key column. Corresponding to 36, it's 2 by 5. So divided by 2 by 5. That's equal to 90 here. And similarly 27 divided by 9 by 5. That's equal to 15. So the key row is the lowest positive value of ratio R. So 90 and 15. So this is the key row. And corresponding to the key row, this is the outgoing variable. Corresponding to the key column, this is the incoming variable in the third simplex table. So we identify the outgoing variable and the incoming variable for the next table. So we'll be writing the same stub here. It's actually x1, x2, s1 and s2, and corresponding to that it's 3000, 2000, 0 and 0. So this s2 is deleted, it's our outgoing variable, and we bring in x1 here. This is the outgoing variable which is deleted, s2, and we bring in x1 in the third simplex, x2 in this simplex table. So it's x2. And new entry in the key row is key row in the old table divided by key element. So it's 27 divided by 9 by 5. So it's 15 here. Similarly, it's 0 divided by 9 by 5, that's 0. 9 by 5 divided by 9 by 5, that's 1. Minus 3 by 5 divided by 9 by 5, that's minus 1 by 3. And 1 by 9 by 5. So it comes as 5 by 9. And similarly, for finding the row other than the key row, we write the old elements of the row. It's 36, 1, these elements 35, 36, 1, 2 by 5, 1 by 5 and 0. 36, 1, 2 by 5, 1 by 5 and 0. And we follow the same procedure, minus, 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 minus. The key row in the new table values, this 15, 0, 1, minus 1 by 3 and 5 by 2. We just write it here, 15, 0, 1, minus 1 by 3 and 5 by 9 multiplied by corresponding to the key column, which is the element which corresponds to x1. It's 2 by 5 into 2 by 5. Here it's 2 by 5, 2 by 5, 2 by 5, 2 by 5. So this comes to 30. This is 1. This is 2 by 5 minus 2 by 5, that's 0. Here it's 1 by 3 and here it's minus 2 by 9. So this is the new values of the first row. Now change in the basic variable, it's x1 here itself. 30, 1, 0, 1 by 3 minus 2 by 9. Again we calculate Zj. Zj is 1. Okay, here the parts per unit is corresponding to x1 we have 3000 here, corresponding to x2 we have 2000 here. So Zj is equal to 1 into 3000 minus 0 into 2000. So it comes as 3000 here. Here it's 0 into 3000 plus 1 into 2000. So it comes as 0 minus 0 plus 2000. 2000. Here it's 1 by 3 into 3000, that's equal to 1000 plus 2000 into 1 by 3. So it comes as 1000 by 3. Similarly here it's 3000 into minus 2 by 9 plus 2000 into 5 by 2. So it comes as 4000 divided by 9. Again we find Cj minus Zj. So here it's 3000 minus 3000, that's 0. 2000 minus 2000, again 0. 0 minus 1000 by 3, that comes as minus 1000 by 3. Here it's 0 minus 5 by 4000 by 9, that's equal to minus 4000 by 9. So what we find here is Cj minus Zj is either 0 or is negative. So we have reached at the optimum value of x1 and x2. So the optimum value of x1 is 30 and that of x2 is 15. And max Z equal to 3000 to x1. x1 is 30 plus 2000 into 15. So it comes as 90,000 plus 30,000 is equal to 1,20,000 is the max. set value. So here we have arrived at the solution to the linear programming problem, and the maximum value of z is also found out. Similarly, you can try for another example. Maximize c equal to 2x1 plus 2x2, subject to the conditions are 3x1 plus 5x2 is less than or equal to 15, 6x1 plus 2x2 is less than or equal to 24, and so x1 and x2 is greater than or equal to 0. Just follow the same steps here and you should be arriving at an answer of x1 equal to 15 by 4, x2 equal to 3 by 4, and max z equal to 33 by 4. Just do it as an assignment. Hope this video you find it useful. Thanks for watching.